All right, good morning everyone again. So today we are going to be learning how to solve quadratics by using the quadratic formula. So far we started with, when you guys were still here in school, we started with solving by factoring, which is very awesome when it'll work. For example, okay, that's factorable, right? But not everything is factorable, right? Because if I throw a 10 right here, there are no factors of 10 that can make 6. So that one's not factorable. And then we learned that we can solve using square roots. That only works a very small amount of the time when we have something like this, where we don't have that x term. So another example of that would be this guy, right? As long as we don't have that second x term, we can solve using square roots, and that's very efficient and helpful. Last time we learned a pretty lengthy process to solve these guys, and that's completing the square. Completing the square can be useful, but it is time consuming. It would work on a problem like this one right here. I could move over the 10, take half of 6, square it, add it to both sides, continue that process, and do completing the square. However, if I asked you to do this problem for completing the square, it would get real ugly real fast, because you would have to divide everything by 3, because we have to divide by the leading coefficient, and then here you get 7 divided by 3, and that would be your b, and then you would take half of that, and then you'd square it, you'd have to add that to both sides. It gets real ugly real fast. So completing the square is great for problems like this, where we have an even number in the front, in the middle for the b term. But when we get to these problems right here, they get pretty ugly, or even things that have decimals in them. Right? When we get to something pretty ugly, this is pretty much when we need to start using the quadratic formula. So the quadratic formula is kind of the good go-to for anything that doesn't work for factoring or square roots, or is too ugly for the completing the square. Okay, it's kind of like Old Faithful is what I tend to call it. All right, so in order to use the quadratic formula, you have to know what the quadratic formula is. Okay, this is what the quadratic formula is. X equals negative b plus or minus the square root of b squared minus 4ac all over the whole thing is over 2a. That's one big thing I see, is that some people would stop the fraction bar right here. Make sure the whole thing's over 2 times a. Okay, in this formula we have a's, b's, and c's. We get this from our standard form of our quadratic equation right there. So the first thing you want to do if you're trying to solve by the quadratic formula is have your equation equal to 0, because that's how you get your accurate a, b, and c values. So get it equal to 0, then the a is the number with the x squared, the b is the number with the x, and c of course is the constant. And then you plug each of those numbers in and you simplify as much as you possibly can. So one of the main things is learning how to kind of memorize this formula, because I won't be giving it to you on a quiz or test. It's one of those formulas that anybody in Algebra 2 right now could just spit it out. It's just like, you just got to memorize it. So there is a song for it. It's kind of embarrassing. It's, if anybody knows that Jack in the Box song, like all around the mulberry bush, the monkey chased the weasel. So I don't know if anybody knows that. It's kind of an old song. But anyway, this can kind of go along with that rhythm. It goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. Anyway, so if you kind of keep saying that until it gets annoying, if I was actually in class, that's what I would keep doing, is I would just keep singing it till I annoy the crap out of everybody, and they would have it in their heads. So maybe just think about it, say it to yourself until you have it completely in your memory. All right, so here we go. Let's use it. All right, so again, when we're doing the quadratic formula, you want it to look like this. You want to clearly see your a, b, and c value and have the equation equal to 0. So what I start by doing is writing down my a, b, and c. So my a is equal to 1, because there's no number in front of the x squared, so it's automatically 1. My b is equal to 6, and my c is equal to 5. Okay, after that, you're really just writing this formula down. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And I suggest when you do your homework that you do write the formula every time, because that's how it helps you commit it to memory. That's just a suggestion though. So here for negative b, I kind of like to think it as like the opposite b. So if it's positive, then it'll go to negative. And if this was a negative 6, then it would turn to a positive. So this negative b, I kind of think about the opposite sign of b. Plus or minus. And we've seen that before because when you have to graph a quadratic in standard form, to get the vertex, we have to do negative b over 2a. So we've actually kind of seen this before. All right, so our b is 6, so I'm going to do 6 squared. Okay. Right here, I actually don't like to write down the, oh yeah, so minus 4, then a is 1, then c is 5, and this whole thing is over 2 times our a. So all I did was I put a where a is in the formula, b where b is in the formula, and c over where c is in the formula. So we simplify what's in the square root first. So 6 squared is 36. Okay, here I like to kind of pause and not write down the minus sign yet, because if there was a minus here and if there's a minus there, that'll actually mean that there's going to be a plus there. So before I decide what sign that is, I want to kind of see how many negatives I have. I only have 1, so this will still be a negative sign. 4 times 1 is 4. 4 times 5 is 20. On the bottom, 2 times 1 is 2. 36 minus 20 is, of course, 16. The square root of 16 is 4. Okay. And then each of these can be divided by 2. So I can make this negative 3 plus or minus 2. Right here, 6 can be divided by 2 and 4 can be divided by 2. Okay, if I had something like this, okay, I wouldn't be able to divide both of those by 2, and that we would have to do that a different way, and I'll show you that. I have that in a different problem later. Okay, and just like with completing the square, you got to make sure your answer is completely done. I can figure out what negative 3 plus 2 is and what negative 3 minus 2 is, so I actually can get my two answers of negative 1 and negative 5. Okay, so this is really just a plug and chug type problem. You write down the formula, plug in your A's, B's, and C's, and the key is just to simplify correctly. All right, let's try another one. So every star problem, I want to make sure it equals 0. Everything's on the left side in order. X squared, then the x term, then the number. This is my A, my B, and my C. So I'm going to write those down. A equals 1, B equals 4, and C equals 2. I'm going to write my formula down just so I can get it committed to memory. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Sorry, I'm a little pitchy. Alright, so negative b, so that's the opposite sign of b, so b is positive, so I'm going to have a negative 4 right there. B squared is 4 squared minus 4 times 1 times 2. And 2 times 1. So I put B where B should go, A where A should go, and C where C should go. And then I simplify inside. 4 times 1 is 4. 4 times 2 is 8. Oops. Okay. So at this point in time, you've got to ask yourself, is 8 a perfect square? It is not. So if it's not a perfect square, then you have to ask yourself, well, can I break it down? That's the whole jail method that we've been working on the last 2 lessons. So we have 2 and 4, and 2 and 2. So is there any number twice? Yes. So right here I have negative 4 plus or minus. One of these 2's is going to escape jail, but only one of them. The other one's not going to make it. And then this guy's still stuck in jail. Okay. So here's the thing. This guy in jail at this point in time now can't be touched. So when I'm dividing by 2, I cannot divide the square root of 2 by 2. I can only divide these free people out here. So 4 is going to be divided by 2, and 2 is going to be divided by 2. So I get negative 2 plus or minus 1 square root of 2. Hopefully you guys know by this point in time I don't need the 1 right here. So you could just do negative 2 plus or minus the square root of 2. Okay, so have the 1, don't have the 1, it doesn't matter. If you're doing something online, you probably want to not put it because it might count it wrong. All right. Students kind of like this because the concept isn't super hard to grasp, but it's the simplifying and it's like the sign errors that really tend to get people. All right. So this one looks a little different than our last two. Hopefully you notice something that we need to fix. In order to get an accurate A, B, and C, I need this to be equal to 0, so I need to move over the 20 before I do anything else. Like so. Now I can get my accurate A, B, and C. Okay, don't forget the minuses. That's a -8 and that's a -20, so both of those need to be negative. X equals -b plus or minus square root b squared minus 4ac all over 2a. Okay, so -b. So my b here is already negative, which means that's the opposite of what the sign is. So I'm going to put a +8 here in front. B squared is -8 squared minus 4 times 1 times -20 all over 2 times 1. Okay, so I get 8 plus or minus the square root. We've talked about this quite a bit. When we square a negative number here, you do want to make sure you put that negative number in parentheses, especially if you're using a calculator, because if you put -8 without parentheses in a calculator squared, it's going to push out a -64. So that's why it's really important that you put the -8 in parentheses, because -8 squared is -8 times -8, which is actually a +64. So this right here, this number, no matter what, is always going to be positive because we just squared it. Here, this is why I don't suggest writing down a negative sign yet, because you should look at the big picture up here and see you have negative times a positive is a negative, but then I'll be timesing by another negative. So that's actually going to be a plus sitting right there. That is the number one mistake I see people make, is that they automatically write down a minus and then they don't think about the signs anymore. So -4 times 1 is -4. -4 times a -20 is a +80. 64 plus 80, what is that, 144? Gotta ask yourself, is 144 a perfect square? Which it is. That's actually 12. Both of these can be divided by 2, so I get 8 divided by 2 is 4. 12 divided by 2 is 6. Okay. Since I can figure out what 4 plus 6 is and 4 minus 6 is, I need to keep going. So we get 10 and -2. All right, I'm going to pause for about 30 seconds or so you can get started on the next problem. Don't forget, we need this to be equal to 0. So I'm going to have to move that 5 over first. Alright, I'm going to get going, but don't forget, if you ever want more time, like you're like, hold on, Miss Curtis, do you have any more time? You can just pause the video. Okay, so I need this equal to 0, so I'm going to move over the 5, just like I talked about. I'm going to write down the formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. I forgot to write down my A, B, and C values. That's my A, that's my B, that's my C. X equals, I need the opposite sign of b. B is a positive 4, so I'm going to put a negative 4 here. B is 4. 4 to negative 5. Alright, 4 squared is 16. Right here, be careful. There's a negative here and another negative here. So when there's two negatives, that'll end up making a positive. 4 times 2 is 8. 8 times 5 is 40. Okay, negative 4 plus or minus the square root of 56 all over 4. At this point in time, we got to ask ourselves, is 56 a perfect square root? It isn't, but we need to try and break it down to see if it breaks down. We get 2 and 28, 2 and 14, and 2 and 7. So we do have a pair of 2's where we can have one of those 2's come out. And then inside, we actually still have a 2 and a 7. So actually inside I still have a 14.